So good day everyone. I am Algie Murillo and we're back on the last part. For the last part of this discussion about applications of derivatives in the STEM Engine Review and Tutorial Center School or Search. So we'll discuss in this last part of the video sets about applications of derivatives through related rates. So the related rates from the word itself are sets of problems where it involves variables or rates that are related in terms of each other. For instance, perimeter and area functions are related rates. Another dv, the derivative of v with respect to r, and the derivative of r with respect to t are related rates since the t changes with respect to r and r changes with respect to v. So, medyo familiar tayo dun sa mga ginawa kong example. So, dito yung V, pwede siyang volume, and yung R, pwede siyang radius. And T, commonly T is used to denote time sa mga calculus problems sa derivative. So, ganun, yun. Commonly, rates are yung na-represent through letters and may D letter over D letter, parang ganun. Maaso. Wait na ha. So, to solve related rates problems, here are the general steps that can be applied to solve word problems about related rates. First, assign symbols to all variables involved in the problem. If applicable, draw the figure and sketch the variables and set up the equations. State in terms of the variables the information that is given and the rate to be determined. Ito yung find what is asked and state the given values. Find an equation relating the variables introduced initially. So, dito pa lang tayo pala ng part kung saan gagawin na natin yung, set up na natin yung equation. Using the chain rule, differentiate both sides of the equation found beforehand with respect to the independent variable. Ito yung i-differentiate na natin yung function na nakuha natin. Substitute all known values into the newly formed equation and solve for the unknown rate of change. Finalize the answer afterwards. So, di ba, parang mapansin natin na halos pareho ang kanilang process sa pag-optimize ng isang situation. So, halos pareho ang steps sa related rates and sa optimization. However, ang pinagkaiba nila is yung aim. So, kung sa optimization, ang kailangan dun is yung minimum or maximum value, kaya gumamit ng derivatives. Sa related rates, kailangan natin makuha yung rate of change ng isang variable with respect sa isa pa using calculus. Maaaring ma-interchange ang processes ng optimization and related rates depending sa context, pero they have a fine line between. Halos pareho lang yung steps pero may super vital na pagkakaiba. So first, punta muna tayo sa mga word problems. Find the derivative of y with respect to t at x is equal to 1 and y is equal to x squared plus 3 if the derivative of x with respect to t is equal to 4. So, medyo pa siya, technical. So, parang wala pa man siya nakikita nating application. Dito muna tayo. So, ang given daw umano is ito, yung equation y is equal to x squared plus 3, x is equal to 1, and the derivative of x with respect to t is equal to 4. Ito na yung equation natin, yung y is equal to x squared plus 3. Ang kailangan na natin dito ay i-differentiate yung objective function with respect to t. So, let's apply the derivative. We'll now have d over dt y is equal to d multiplied by x squared plus 3 all over dt. So, the derivative of y with respect to t, kapag in-apply na natin yung derivatives, is equal to 2x multiplied by the derivative of x with respect to t. Substitute the derivative of dx over dt to the derivative to get dy over dt. So, yun na yun. Ang catch pala dito, di ba? Noong una, nag-apply tayo ng calculus para makuha natin yung derivative ng isang variable in terms of isa. So, halimbawa, kinuha natin yung derivative ng y with respect to t using calculus. So, nagkaroon tayo ng new letters sa equation, yung mga d. Ngayon, after natin ma-apply yung calculus, iti-treat natin yung mga d na yun as a variable. So, after natin i-differentiate yung function, i-treat natin siya algebraically na. So, parang ipapareho mo na sila sa mga equation na xy lang. X, Y, A, B, ganun. So, naging algebraic yung notation nitong dy over dt. So, parang naging variable lang siya. So, dy over dt is equal to 2x multiplied by dx over dt. Dy over dt is equal to 2 multiplied by 1 kasi ang value ng x is 1 multiplied by dt, dx over dt. Ang value ng dx over dt natin dito is 4. So, multiply all, simplify, we will now have dy over dt is equal to 8. So, the dy over dt at x is equal to 1 and y is equal to x squared plus 3. If dx over dt is 4, is equal to 8. Ito yun. So, next problem tayo. Find dz over dt at the coordinate x, y is equal to 15, 8, and z squared equals x squared plus y squared if dx over dt is 4 and dy over dt is 3. So, medyo familiar yung objective function natin. So, ang given daw dito, x is equal to 15, y is equal to 8, dx over dt is 4, dy over dt is 3. Ang kailangan natin mahanap is yung dz over dt. Diba may x, may y, may dx over dt, may dy over dt. So, kailangan natin, para mahanap yung dz over dt, kailangan natin ng z. Find z given the values of x and y. Familiar siya. Mukha siyang Pythagorean equation kasi Pythagorean equation talaga siya. So, z squared is equal to x squared plus y squared. Z squared is equal to 15 squared plus 8 squared. Z squared is equal to 289. Z is equal to plus minus 17. Diba? So, since wala pa naman masyadong restriction sa problem, we should consider both the positive and negative sides of 17. So, the value of z is plus or minus 17. Differentiate the function with respect to t. Yun na yun. Dito na tayo mag-apply ng derivatives. Dito na papasok yung mga d na letter. So, the derivative of z squared with respect to t is equal to the derivative of x squared plus y squared with respect to t. So, yun na yun. 2z multiplied by dz over dt is equal to 2x multiplied by dx over dt plus 2y multiplied by dy over dt. Ito na. So, dito na papasok yung gagawin nating algebraic ang pag-solve. Simplify the function and find dz over dt by substituting the variables by the given function. So, binalikan natin yung mga given values. X is equal to 15, y is equal to 8, z is equal to 17, dx over dt is 4, dy over dt is 3. Ang kailangan na lang is dz over dt. So, isubstitute natin lahat. So, by using algebra and manipulating the variables, we will arrive at the answer. dz over dt is equal to 84 over 17. 84 seventeenths. Parang sa mga ano. So, yun, the value of dz over dt is equal to 84 over 17. Number 3, dito na tayo papasok sa exciting part. Papasok na sa application talaga. Number 3, an airplane is flying overhead at a constant elevation of 4,000 feet. A man is viewing the plane from a position 3,000 feet from the base of the radio tower. The airplane is flying horizontally away from the man, and if the plane is flying at the rate of 600 feet per second, at what rate is the distance between the man and the plane increasing when the plane passes over the radio tower? So, kailangan natin i-visualize yung problem, lalo na sa mga ganitong situations, kailangan muna nating sketch ang graph. Tingnan yung mga variables na pwedeng gamitin and saka na natin iset up yung equation. As shown, x denotes the distance between the man and the position of the ground. Ito yung lalaki pala, by the way. Tapos ito yung distance. The variable s denotes the distance between the man and the plane. Note that both x and s are functions of time. So parang these are functions of x and s are functions with respect to time or t. There is no variable for the height of the plane because this already has a constant value which is 4,000 feet. Hindi na kailangan lagyan ng variable. Since an object's height above the ground is measured as the shortest distance between the object and the ground, the line segment of length 400 feet is perpendicular to the line segment of length x feet, creating a right triangle. Kasi like since kailangan natin makahanap yung nearest, ang most suitable form of triangle dito is the right triangle. Since x denotes the horizontal distance between the man and the point on the ground below the plane, dx over dt represents the speed of the plane. Ito yun. Ito. The speed of the plane is 600 feet over second per second. Therefore, dx over dt is equal to 600 feet per second. Yun na yun. Kasi dx over dt raw ito. And since we have the speed of the plane which is 600 feet per second, we set up the 600 feet per second as dx over dt. Since it is asked to find the rate of change in the distance between the man and the plane when the plane is directly above the radio tower, ang kailangan natin mahanap dito is yung ds over dt, which is ito, with respect to t when x is equal to 3,000 feet. Part siya na given. From the figure, the Pythagorean theorem can be used to write an equation relating x and s kasi nga right triangle siya. So, setting up the equation will give us x of t squared plus 4,000 squared is equal to s of t squared. Differentiating this equation with respect to time and using the fact that the derivative of a constant is 0, the derived equation will give us x multiplied by dx over dt is equal to s multiplied by ds over dt. Yan, tama siya. Find the rate at which the distance between the man and the plane is increasing when the plane is directly over the radio tower. In short, find ds over dt when x is equal to 3,000. Dito na tayo, since na-derive na natin, kailangan na lang natin is solve by algebra. Since the speed of the plane is 600 feet per second, yun na nga, diba? Ang dx over dt natin is 600. Using the Pythagorean theorem to determine the distance when x is equal to 3,000 and the height is 4,000, we will now have the Pythagorean equation ulit. 3,000 squared plus 4,000 squared equals s squared. S is equal to plus or minus 5,000 per since ang kailangan natin sa problem ay yung distance and distance are only positive values. We only need the s equals 5,000 as the probable answer. And technically, yun yung answer. So, para sa s, pero ang kailangan talaga natin dito is ds over dt or the rate of change of the speed with respect to time. So, nahanap na natin yung s, which is 5,000. Gagamitin na natin to para mahanap yung ds over dt. So, plugging in values will give us 3,000 multiplied by 60 is equal to 5,000 ds over dt. So, ds over dt is equal to 3,000 times 6,000 divided by 5,000. 3,000 times 600 divided by 5,000, and this will give us the rate of change, which is 360 feet per second. The rate of increase in the distance of the plane when the plane is flying at 650 feet per second is 360 feet per second. So number 4 problem, water is draining from the bottom of a cone-shaped funnel at the rate of 0.03 feet cubed per second. The height of a funnel is 2 feet and the radius at the top of the funnel is 1 feet. At what rate is the height of the water in the funnel changing when the height of the water is 1/2 feet? Ang kailangan natin dito is rate of change ng height of water with respect to time. So, sketch the problem. Mukha na siyang funnel, yun na yun. So, let H denote the height of the water in the funnel, yung tubig na mismo. R denote the radius of the water at its surface, ito lang, and V, the volume of the water. So, ito yan na lahat na nasa black part. Yun yung volume, which is denoted in as V. The goal is to determine dH over dt when h is equal to 1/2 feet. It is known in the given that dV over dt is 0.03 feet per second. Yun, 0.03 feet per second. Yung 0.03 feet cube per second, pero since dimensional analysis tayo, pabawas yung tubig sa funnel, so the rate of change is decreasing at a rate of negative 0.03 feet cube per second. The volume of the water in the cone is yung traditional formula natin sa paghanap ng cone. V is equal to 1/3 pi r squared h. From the figure, we see that there are similar triangles. Yung funnel mismo and yung shape ng tubig. Similar triangles sila. Therefore, the ratio of the sides in the two triangles is the same. Therefore, RH is equal to 1/2 or R is equal to h over 2. Using this fact, the equation for the volume can be simplified to the volume is equal to 1/3 pi h over 2 squared h, which further is equal to v is equal to pi over 12 h cube. Applying the chain rule, kasi may nakita na tayong equation, while differentiating both sides of the equation with respect to t, we have is dv over dt is equal to pi over 4 h squared dh over dt. Ito na yung differentiated equation, yung derivative. Since meron na tayong derivative ng function, ang goal na natin ngayon is mahanap ang dH over dt when h is equal to 1/2. Since water is leaving at the rate of negative 0.03 feet cubed per second, it is known that dV over dt is negative. Yun na nga. Negative 0.03 is equal to pi over 4 multiplied by 1/2 squared dH over dt, which implies that negative 0.03 is equal to pi over 16 multiplied by dH over dt. Therefore, dH over dt is equal to negative 0.48 over pi, which is further equal to negative 0.153 feet per second. Final answer, the height of the funnel is changing at the rate of negative 0.153 feet per second when the height of the water is 1/2 feet. So, since decreasing our rate of change, pabawas yung height ng water. Number 5, consider the given isosceles triangle of base 10 inches and side lengths x inches. If x is increasing at the rate of 4 inches per minute, at what rate is the triangle's perimeter changing? How about the rate of change of the height? And how about the rate of change of the area? So, mapapansin natin na hindi lang isang variable yung hinahanap, kundi tatlo on a separate cases. So, possible to since ang isang equation, ang isang variable can be related on several other terms. In this problem, there are several variables that are yet to be found, and having multiple unknown terms can still be possible since more than one variables can be related to a single one. So, yun na yung parang related yung height sa side, related yung side sa time. Related yung area sa perimeter, related yung perimeter sa length. So, pababa or pataas or paiba-iba yung dimensions pero they are related with respect nga to time. So, ito na tayo sa illustration. Let x be the side of the triangle and recall that the perimeter of the triangle is the sum of its sides. So, side plus side plus side. Since given yung 10 and given yung dalawang sides which is x, we can now have the perimeter of the triangle which is equal to p is equal to 2x plus 10. given values, yung dx over dt natin is nagbabago into 4 inch per meter, ay per minute. And ang kailangan natin is d capital P over dt when x is equal to 13 inches. May formula na, may equation na tayong kailangan magagamit. So, let's differentiate the per meter equation with respect to time. Getting d capital P over d capital dt is equal to 2 multiplied by dx over dt. Now, let dx over dt equals 4 from the given. So, the substitute, we now have d capital P over dt is equal to 2 multiplied by 4. D capital P over dt equals 8 inches per minute. So when the triangle's height is increasing by 4 inches per minute, the perimeter is changing by 8 inches per minute too. So, ang kailangan naman natin mahanap is yung height, yung rate of change ng height, and rate of change ng area. Consider the given isosceles triangle of base 10, edges x, and height h. May bagong variable na yung h, which is height. Assume that h and x are functions of time t, and para mas madalian tayo sa pag-solve, divide the triangle into two right triangles of height h. Na yun. Isosceles triangle can be divided into two triangles that are right triangles. Using the Pythagorean theorem, we get the following height equation. 5 squared, ito, plus h squared, ito, is equal to x squared, ito. So, h squared is equal to x squared minus 25, and that is the working equation. Given umano, ang given umano, dx over dt is equal to 4 inch per minute, and ang kailangan natin mahanap is dh over dt when x is equal to 13 inches. Differentiate the equation of the height. We have the differentiated equation h over dh over dt is equal to x multiplied by dx over dt. Nag-apply na tayo ng derivatives dito. So, let x equals 13 in the height equation. 25 plus h squared equals x squared. Getting 25 plus h squared equals 169. So, we now have the height, which is positive and minus negative 12. Pero since ang dimensions natin ay positive values only, limited lang siya into h is equal to 12. Now, let dh over dt equals 4, x equals 13, and h equals 12. So, meron na tayo ditong nakuha na natin yung given values. I-substitute lang natin para mahanap yung initial given, which is dh over dt. Now, ending with our answer, dh over dt equals 13 over 3 inches per minute. So, when the triangle's height is increasing by 4 inches per minute, the height is changing by 13 thirds inches per minute. So, papunta na tayo sa third part ng tanong, which is the rate of change of the area. So, consider the given isosceles triangle ulit of base 10, edges x and height h, and assume that h and h are functions of time t. The area na yung hinanap natin yung formula, is equal to area equals 1 half base times height, which is equal to a is equal to 1 half multiplied by 10, kasi 10 daw yung 10 inches yung height ng base. Ito, multiplied by h is an unknown variable pa. So we now have a is equal to 5h. So the given function here is the given values here are dx over dt is equal to 4 inches per minute. And ang ating kailangan mahanap is d over dt when x is equal to 13. D capital A kasi capital A ang area. From the previous sub-item, nahanap na natin yung rate ng h, which is equal to 13 over 3. So, substitute na lang natin yung dh over dt into the equation. So, d capital A over dt is equal to 5 inches multiplied by 13 over 3 inches per minute. So, ang equal dito automatically ay ang Rate of area with respect to time is equal to 65 over 3 inches squared per minute. So when the triangle's height is increasing by 4 inches per minute, the area is changing by 65 thirds inches squared per minute. Nagtataka ba kayo kung bakit sa napunta yung 5? Ito siya actually yung derivative nito. The derivative of a is equal to 5x is simply dA over dt is equal to 5 dH dt. Yun na yun. So, sixth item and the last item that we will tackle. A spherical balloon is being filled with air at the constant rate of 2 centimeter cubed per second. How fast is the radius increasing when the radius is 3 centimeters? So, ito yung graphical presentation natin. Ito yung sphere na balloon na radius umano ay 3 centimeter. So, ang hinahanap natin dito is constant, constant na yung rate ng pag-increase ng radius kapag 3 centimeter ang radius given the constant rate which is 2 centimeter cube per second. Differentiating both sides of the equation kasi alam na natin yung formula ng volume ng sphere which is equal to may nakalimutan pa tayong slide so i-recall muna natin ang volume ng sphere with radius r is equal to v is equal to 4 thirds pi r cubed centimeter cube given nato by ano by universal truth. So, since the balloon is being filled with air, both the volume and the radius are functions of time. And if nag-i-increase yung radius, i-increase din yung volume. So, you now have the working function. V of t is equal to 4 thirds pi r t cubed square root 3 cube centimeter cube pala. Hindi square root. Centimeter cube. So, differentiating both sides of this equation with respect to time and applying the chain rule, we can say that the rate of change in the volume is related to the rate of change in the radius by the equation capital V over dt is equal to 4 pi r of t squared multiplied by dr over dt. Ito, dinerive natin siya, ang kinalabasan, ito. So the balloon is being filled with air at the constant rate of 2 centimeter cube per second. So d capital V over dt is equal to 2 centimeter per centimeter cube per second. So therefore, we can now have 2 centimeter cube per second equals 4 pi r of t squared, centimeter squared na kasi nagbawas ng variable, dr over dt, centimeter per second ang unit. Which implies that dr over dt is equal to 1 over 1 over 2 pi r of t squared centimeter per second. And when the radius is 3 centimeter, base sa given, r is equal to 3. And plugging in, we will now have dr over dt is equal to 1 over 2 pi 3t squared, which is equal to 1 over 18 pi centimeter per second. And by further solving, we'll now have dr over dt is equal to 0.0176 centimeter per second. So the rate of change of the radius of the sphere is 0.0176 centimeter per second. And that wraps up our three parts of the discussion about applications of derivatives. Actually, I must say that marami pa talagang possible examples sa mga applications kasi nga applications ito and maraming branches of applications ang derivatives in real life. Doon pa nga lang sa optimization, marami ng possible problems. Pero ang state ko lang dito is yung most common na nakikita sa mga academic math problems. Sa local linear approximation, ganun din. And dito sa related rates, ganun din yung narrative. So, para mas ma-enhance yung skills, maaari kayo mag-ano sa iba't ibang resources and try to contact everything. So, ayun, that wraps up our module 6 of the discussion. Hope to see you around and para sa context dito sa ating STEM Engine Review and Tutorial School para ma-assess kayo sa mga natutuhan nyo based dito sa Lesson 6. May ipopost kami quiz na related dito which is ang balak is 2 items per part. So we'll have 6 items. Yun lamang.